So welcome to the next tutorial that is on source transformation. This is tutorial 10th and this is a very important tutorial because if you have any quite complex circuit, you will be able to solve the problem much easily that we are going to see. So before we start solving the problem on source transformation, a little bit overview of the source transformation. Let me give you this. If you have any complex circuit, you can break that circuit in the form of a voltage source, that is a DC voltage, in series with a resistance. So you will have a series resistance. If you remember, when we discussed the Thevenin's theorem, this is similar to the Thevenin's theorem. You have a voltage and there is a resistance which is in series. This circuit, that is a voltage source in series with a resistance, can be converted to a current source in parallel with a resistance. So you will be having a resistance which is in parallel. So the Thevenin's theorem and the Norton's theorem, they are basically taking this source transformation into account. So the theorems basically depend upon the source transformation. So here the voltage source is converted to the current source and the resistance which is in series has now come in parallel. Okay, so resistance which is in series has come now in parallel. Only thing that you have to consider is that because this comes from a very complex circuit, so the rest part of the circuit should not be disturbed. Other thing is that the direction of the arrow of the current source will be in the direction where the positive terminal of the voltage source is there. So from the negative terminal to the positive terminal, you should have the direction of the current source. If your negative terminal is upward and positive terminal is downward, the direction of the current source will be in the downward. So any complex circuit you can break up into simple circuit using source transformation, and then you can determine the unknown variables. So one thing, a point you have to keep in mind, that the unknown variable that you have to solve in this problem, that you should not disturb in the complex circuit. So whenever you have a complex circuit and suppose you need to determine the current Ix or voltage Vy, that part of the circuit you should not disturb, because that will be the end where you will be solving the problem. So these all concepts we will learn today in terms of some problems. So this is the problem first in source transformation. So using source transformation, you have to obtain the variable Ia. So in this network, you see the current which is originating from the 10 volt source is basically the current Ia. So you should not disturb this current because this is the variable. Means you should not disturb the 3 ohm resistor, because they are only the current you are going to determine. You can solve this problem using KVL, KCL, Thevenin's, Norton's, or superposition. However, today's tutorial is based on source transformation. So we are going to solve this problem based on source transformation only. And you will see that irrespective of lot of theorems are available, you are not going to write multiple equations, but you will get the final solution. So this determining this current Ia, if you go by KVL or KCL method, the number of steps will be quite large. However, we'll solve this problem using source transformation. So this is our original circuit where we need to determine the current Ia using source transformation. So what are the steps? Let us see. Step 1. Okay. We closely observe this circuit first and try to identify the point or the branch where we can break up and try to obtain the equivalent sources. Means voltage will be converted to current or the current will be converted to voltage without disturbing the other part of the network. Let us observe this circuit. So I can see that I have a 2 ampere current source and 8 ohm resistance which are in parallel to each other. Now I know that a current source can be converted to a voltage source in series with a resistance, where the voltage source magnitude will be the current multiplied with the resistance, and resistance will be in series. So that part of the network we will be replacing with a new part, that is the 8 ohm multiplied with the 2 ohms, 2 ampere will give me 16 volt as the voltage source, and there will be a resistor 8 ohm which will come in series with the voltage source. Now the terminal of the voltage source will be decided with the arrow symbol of the current source. So I have said that the direction of the arrow will be in such a way that the point head will point the positive terminal and this will be the negative terminal. So we have a 16 volt voltage source with positive and negative terminal. Now after that, this is the step 1 that we have taken. After that, let us observe the circuit carefully and try to minimize this circuit into much reduction form. Only thing point we have to consider is that this resistor we are not going to touch, because here we have to determine the current. So if I observe this circuit again carefully, what I observe is that if I consider this part of the network, I am having 8 ohms and 4 ohms in series. That is, the series combination will be 12 ohms, 8 plus 4, and I am having one voltage source of 16 volt. So can I convert this 16 volt and 12 ohms into an equivalent current source in parallel with a resistance? Yes, obviously we can do that. So this part of the network will now be modified, where the current source will be equal to the voltage by the resistance. So we have the voltage as 16 volt and the resistance as 12 ohms. So we will be getting 4 by 3 ampere as the current source. Now again, if we closely observe the voltage source polarity, we are finding that negative positive we have for the 16 volt. It means the direction of the arrow should come downward for the current source. So here we have the downward direction for the current source of 4 by 3 amps, and there is a resistor 12 ohm which is in parallel to it. Now if we observe this circuit which is obtained from the step 2, I find that the 6 ohm and 12 ohm resistor is in parallel with the current source of 4 by 3 ampere. So I will reduce this circuit from step 2 to step 3, where what I will be doing is that I will take the parallel combination of these two resistors. So I will be having 6 multiplied with 12 divided by 6 plus 12, which will give me the 4 ohms. So I am having 4 ohms resistor, that is I am having a 4 ohm resistor in parallel with a current source which is equal to 4 by 3 ampere. So these I can convert into equivalent voltage source in series with a resistance. So resistance will remain the same, that is 4 ohms, whereas the voltage source will be equal to the current multiplied with the resistance. Now the current that we have is 4 by 3 and the resistance we have equal to 4. So the voltage source magnitude is equal to 16 by 3 volt. So here we have 16 by 3 volt as the voltage magnitude. Moreover, the direction of the arrow is given downward. So here we will have positive terminal and here we have negative terminal for the voltage source. Now we have reduced this network into a single mesh problem, which we can apply the Kirchhoff's voltage law in a mesh, and we can determine what is the current which is flowing in this mesh. So the current which is flowing in this mesh is the same current which is flowing through 3 ohm resistor, which is the unknown variable that we have to determine. So the answer to this problem is 2.19 ampere. So if we see that we have written only one equation to obtain the final unknown variable. So if we come across this type of complex circuit, although multiple steps I have shown here to obtain the solution for MCQ type of problems where we have multiple choice type of problem, you can directly go to the third step by observing the network and you can obtain the final solution. Let us solve the second problem. You have to determine the current which is flowing through resistor 2. So what is the current which is flowing through resistor 2 using source transformation? So we have a voltage source of 20 volt in series with a resistance of 5 kilo ohms, and there is a current source of 2 milliampere and the resistor is 7.5 kilo ohms. As I said that the unknown variable here is IR2. So this part of the network you should not disturb. So this part of the network should be present in the circuit in each and every step, and then you have to simplify the network to obtain the solution. So our original circuit is this one. How we can solve this problem? So if we closely observe the network, I see that this voltage source and resistance is in series. I can convert that into equivalent current source in parallel with the resistor, and the remaining part of the network will be there. So what is the current that I will be getting? Current will be equal to 20 by 5 kilo ohms, which is equal to 4 milliampere in parallel with the 5 kilo ohm resistor. So I will be having this part of the network which is coming from the main circuit, and the remaining part of the network will be as it is from the circuit. Now further observation leads us, because I'm not going to disturb this part of the network, I could have find the parallel connection of these two, but I will not do that because I will not disturb this part of the network where the unknown variable is to be determined. What I'm going to do is that I will be observing the current source, these two current source, which are upward direction. So I can apply the Kirchhoff's current law KCL at this common node. So the two current source will be adding up to each other. So 6 milliampere is the current which is adding up here, and the rest part of the network will be as it is because we have to obtain the unknown variable here. Now the problem has reduced to a much simpler format where we have to obtain the unknown variable through resistor R2. I can apply the current division rule. So current division rule suggests that the source current is 6 milliampere multiplied with whatever the resistor is in parallel to it. So you have the resistor R1 which is in parallel, so that will go in the numerator divided by the sum of the resistance R1 plus R2. So I will be getting answer 2.4 milliampere, which is the current that is flowing through resistor R2. The same problem if I have not asked the resistor R2 current, rather if I have been asked that what is the current which is flowing here, that is in the resistor R1, then in that case I should not have started from this end, I should have started from this end. That is, this current source and resistor should be converted to an equivalent voltage source in series with the resistance, and then I will be having one mesh problem. So I will be having one voltage source in series with the resistance R1, and there will be one resistor R2, and there will be one voltage source. So I will be having one mesh problem. So depending upon what variable you have to determine, you have to reduce the circuit in that particular format. Let us solve the problem third. Here you have to determine the potential of A. So you have to determine what is the voltage drop across the 100 ohm resistor using source transformation. So we will not disturb this part of the network, which is the unknown variable part, and we will try to observe the other part of the network and try to simplify the circuit as simple as possible. So let us solve this problem. So this is my original circuit, and if I observe the original circuit, I can see that there is a current source which is in parallel with a resistance. So I can obtain the equivalent of that is with a resistor and a voltage source. Here we'll have positive terminal, here we have negative terminal of the voltage source. So voltage source magnitude will be equal to the current multiplied with the resistance of that part which we are taking into account, where the resistance will remain the same 100 ohms. Now if we observe further, what we observe is that there is a voltage source here. So this voltage source is equal to 8 volt. Now if I don't see the other part of the circuit this end, so I see that these two voltage source can be combined together with this two one resistor to simplify the network. So the step one that we are going to get is from this part of the network. Okay, so this part of the network, if we simplify, we are going to get a 11 volt source with a resistor of 100 ohms which is in series, because when we do the calculation for these two end, we will be getting that 3 volt is in series with 100 ohm resistor. So when we have this 8 volt and 3 volt will add up, so it becomes 11 volt in series with 100 ohm resistor. Now this part of the network we are not going to disturb. So what we are going to do further, it will be helpful if we obtain the entire network into parallel format. So this part of the network where you have 10 volt in series with 100 ohm, you can convert that into a current source in parallel with a resistance, and this part of the network will also have a current source in parallel with a resistance. So here you have the current is equal to voltage, that is 11 volt divided by the resistance of 100 ohms. Here the current source will be equal to the voltage 10 volt divided by the resistance 100 ohm. This part of the network we are not going to disturb. Now we have been reduced into a much simpler form of the network where we have to obtain the potential VA in the 100 ohm resistor, which we are not going to disturb and keep as it is, whereas the other part of the network, that is 100 milliampere and 110 milliampere, will add up to become 210 milliampere, and these 100 ohm resistor and 100 ohm resistor are in parallel, so we'll get 50 ohm resistor equivalent resistance. Now our circuit is reduced into a smaller format. I can apply the current division rule to determine the current first here, what is the current which is flowing here, and then the voltage will be equal to the current which is multiplied with the resistance. So I will apply the current division and then the Ohm's law. So the voltage of the resistor 100 ohms that we have is, I'm applying the current division rule. So the source current is 0.21 ampere. Then in the numerator, I will be having what resistor is in parallel with this, that is 50 ohms. So on the numerator we have 50 ohms. On the denominator we will have the sum of the two resistors, that is 50 plus 100. Now since I have to determine the voltage, I will be multiplying with the resistor, that is 100 ohms. So I will be having 7 volt as the voltage. So you can see that although this circuit is looking quite complex, we have not written a single equation also, and we have come to the final conclusion of 7 volt. So you can reduce the complex circuit into smaller format, and then you can apply any of the known theorems to find the final answer. So when you have, again I'm repeating, when you have MCQ type of question, even it is not told that you have to solve the problem using source transformation, you can always reduce the network into simpler format, and then you can obtain the solution, and that will be very fast and tricky. Let us find the other one. You have to determine the potential V0. So potential V0, that is the source voltage, given the current I is equal to 5 by 2 ampere. So here you have the current which is flowing is equal to 5 by 2 ampere using source transformation. So if you have a subjective type of questions, if you have subjective type of question, here the source transformation will be written. If it is a multiple choice type of question, even you don't write the source transformation, you can always apply the source transformation. So we have to observe the circuit and try to determine the potential. So let us observe this circuit first. What is here that we have? So this current source of 2 ampere and the resistor 16 ohms are in parallel, which can be converted to a voltage source, that is equal to 16 multiplied with 2. So we have 32 volt in series with a resistance of 16 ohms. So we have 32 volt and 16 ohms in series. You see the direction of the current source, it is in this direction. So we have in this direction we can take the current source. Now the remaining part of the network, we have 8 volt and 20 ohms. So that we are going to keep it here, 8 volt and 20 ohms. Now this part, entire part, we can reduce into a smaller format. Now if we observe here the 6 ohm and 3 ohms which are in parallel, so we can have the equivalent of that, that is 6 multiplied by 3 divided by 6 plus 3, which will give us 2 ohms. So we will be having 2 ohm resistor in series with a 10 ohm resistor, where we have the 10 ohm resistor here, and there is a current source of 3 ampere which is flowing between this node and this node, right? We are not going to disturb this part of the network. We'll keep it as it is. Now our circuit will have to be reduced into much simpler format. So let us observe that these 32 volt and 8 volt will add up each other with a proper polarity. So I will be having 24 volt because I'm having 32 minus 8, that is 24 volt. So we have negative positive terminal, and then it is opposing positive negative terminal. Now the 16 ohm resistor and 20 ohm resistor are in series, so we have 36 ohms here in this network. Now let us see this part of the network where we have 10 ohm and 2 ohms in series, which is in parallel with 3 ampere current source. So equivalent voltage source is equal to the current 3 ampere multiplied with 10 plus 2. So we have 36 volt in series with a 12 ohm resistor. The polarity will be given in the direction of the current source. Now the rest part of the network we have, that is 7 ohms and V naught. Now these network can be further reduced into much simpler format. How do we can do that? We have a 24 volt voltage source in series with a 36 ohm resistor. So that can be broke up into a current source in parallel with a resistor. This one, this part of the network, we can reduce it, and we have 12 ohms and 7 ohms in series, that we can give us 19 ohms resistor. We have a 36 volt which will keep as it is, and there is a voltage source of V naught. So we can reduce this network into much simpler format of one mesh problem. How? If these two resistors are in parallel, so the combination of that will give 36 into 12 divided by 36 plus 12 you will be having, and that is in parallel with a current source of 2 by 3 amps. So you can obtain the equivalent voltage source in series with a resistor. So this entire part of the network you can reduce it in this format, and this part of the network you can keep as it is, and this is a single mesh problem. You can apply the KVL equation in this loop where the current is given to you as the 5 by 2 amps, and you can apply the sum of all the voltages in a closed loop is equal to 0. Then your unknown variable V naught you can determine, which is equal to 28 volts. So you have seen that in this problem, although the circuit is looking quite complex, even we have not written much equations, only one equation we have written, and we have obtained the final solution. So this depends how you are observing the circuit, how efficient you are there to observe which part of the network you can reduce into simpler format to get the final solution. Only thing is that the part where you have to find the unknown variables, that you are not going to disturb. So this part of the register you are not going to disturb. This is the final problem for today's tutorial. You obtain a single current source for the network shown below and get the magnitude of the current source and the resistor for the circuit. Okay, so you need only one current source and one resistor. Okay, so that will be in parallel. So this is the network, very simple network. You can observe that 18 volt and 6 ohms are in series, and 10 volt and 5 ohm are in series. You have to obtain a current source in parallel with a resistor to reduce this network into this format. Let us move to the solution. What we can do is that first we will take this part and reduce that into a format of I1, that is the current parallel with the resistor R1. This part of the network I can take and reduce in the form of I2 parallel with the resistor R2. So I have to find out the magnitude of I1 R1, and I have to find the magnitude of I2 R2. Now if we observe the polarity of the voltage source, so we have 18 volt voltage source, so current source direction will be upward. Now here we have positive negative terminal of 10 volt, so the current source direction will be again upward. So you will have the upward direction of the current source. So here first you obtain what is the current is flowing in the network I1, current I2, what is flowing from the voltage by resistor problem. Now the resistance will be the same whatever we have, only this resistor will come in parallel mode, and then we can find what is the I equivalent. I hope the problem is having this one is negative and this one is positive. Then the current source, this one will be downward, this current source will be upward. So you can apply I1 minus I2 is equal to 1 amps. Now the net resistor is in, these two resistors are in parallel, so I can apply R1 R2 by R1 plus R2 to get the final answer. So I am having only one current source, that is I equivalent. Now how to decide this current source direction? So here I can see that I1 magnitude is more than I2 magnitude, so the current will be upward in the direction of the current, and then I1, and then you will be having a resistor in parallel which is the R equivalent, and we have reduced this network into a single current source in parallel with a resistance. So in source transformation problem, generally it is very easy in MCQ type of questions where you can reduce a much complex network into simpler format, and then you can obtain the solution without writing the numerous number of equations as obtained by KVL and KCL.